In the previous video, we have looked at linear regression model, where one variable is influenced by a single independent variable. Now, there are cases where we have two variables influencing the outcome of a dependent variable. So that's when we carry out multiple linear regression. So in this example, we will look at multiple linear regression. We will use this template to carry out multiple linear regression. So for this example, we will look at a classroom scenario. So the dependent variable is exam performance. So we are saying that the exam performance of the students is dependent upon one is revision time, the time taken to do revision, and two is lecture attendance. So this example, we are saying that the exam performance of students is dependent upon revision time and lecture attendance. Now the hypothesis, the null hypothesis is no correlation. That means the exam performance is not influenced by these two variables. That is the null hypothesis. And the alternative hypothesis is that it is influenced by these two variables. Now we will carry out this test at around 90% confidence level. Now to put in the raw data, I'll just copy the data from another sheet and paste values in the data table. Now this template is set up to interpret the results for you. So let's look at the results. Looking at the hypothesis result here, the null hypothesis for both of the independent variables is rejected. Now what it means here is that the p-value or the probability value of being wrong in rejecting the null hypothesis is lower than the alpha value here. So essentially we are saying, looking at these values here, this p-value, these p-values are low or less than this alpha value. That is why we are rejecting the null hypothesis. So what does that mean? This means that there is a relationship. So for this example, that means exam performance is influenced by these two independent variables. That is why the null hypothesis has been rejected for both of the independent variables. Now this test is carried out at around 90% confidence level, which is essentially this value here. Now looking at the correlation, correlation explains the nature of the relationship between these variables here. So looking at the result, it's saying strong positive. So what does that mean? It's strong because the multiple R value, the coefficient of the correlation, or the correlation coefficient is almost 1, 0.99. That is why it is strong relationship. And positive meaning that these two variables, the independent variables, influence exam performance in a direct correlation, meaning if the student spends more time during revision and is faithful in attending lecture, then obviously the exam performance would increase. That's what positive here means. So the strength of this correlation is strong positive. Now these values here represent the unit influence that each of the independent variables has on the exam performance, the dependent variables. If we look at unit influence of x1 on y, which is the unit influence of revision time on exam performance, for every change in exam performance, revision time has an influence of around positive 0.65 units. Now, the same explanation applies to that of variable independent variable 2. So the lecture attendance influences around 1.1 units of the exam performance. So for every change in exam performance, lecture attendance influences around 1.1 units. That's what this values means or represent. Now looking at the regression output, the intercept, this is the Y value. This is essentially the exam results when we omit, or we are saying that if the student does or do revision and does not attend lecture, then the exam performance is this value here. That is, if the student does not do his or her revision and does not attend lecture, then the exam performance is around 31.98 points. So essentially, we are saying that there is no influence of the two variables on the dependent variable. Now looking at the slope here, it's just the same values of this one. It's just the same, and then also the explanation remains the same. We look at the model validation value. This value is the R-square value here. It's 0.98, but in percentage is around 98.92%. What this means is that the exam performance of a student, 98% of this performance is influenced by these two independent variables, meaning almost all of the result from the exam performance is dependent on revision time and lecture attendance. So around 98% is influenced by these two dependent variables, rather two independent variables. So that's what this model validation data represents. Now the confidence intervals. These are the intervals where the true values of the intercept and the slope lies. So what it means is, for example, intercept. The true value of the intercept lies between 31.98 plus or minus 3.09. That's what it means. So the true value of intercept lies between 31.98 plus or minus 3.09. Now the same explanation applies to the intervals for the two slopes here. So if, for example, let's calculate it here. If you want to know the upper limit of the intercept, then it's equals to the intercept plus this value, the limit. So you see this upper value here, 35.07 is here. It's just the same. Now, if we were to subtract it minus the 31.98 minus the interval, then we would get the lower limit, which is here, 28.888 is the same here. So basically, these are the limits where the true value lies, true values of the intercept and the slope. Now on this side, these are the plots. So at the top you can see are the X line plots, so X1 for the variable independent variable 1 and for independent variable 2. Down below is the residual plot. This is essentially the plot of the errors for variable 1 and for variable 2. And on this side is the parity check. So this plot here is the plot of the actual performance of the students against the predicted performance. Now the predicted performance is the one calculated using the regression equation that accounts for the influence of the two independent variables, which is essentially these two values here. Now to determine, show the equation, the multilinear regression equation is equals to y, which is equals to this value here, the intercept 31.98, plus the coefficient of the first independent variable, which is 0.65 here. So 0.65 multiplied by the variable 1, which is x1, so x1, plus the coefficient of variable 2, which is 1.1 here, so 1.1, multiplied by the variable itself, which is x2. So this is the multiple linear regression equation. So essentially this model values here, it's calculated using this equation. So in the future, we can say that this equation will predict the performance of the students when we take into account the time taken to do revision and lecture attendance. So this is where these model values came from. They came from this multiple linear regression equation. Now all of these results, you can get it if you do data analysis using the Excel analysis toolpack, doing a regression here. You will still get the same results. However, this template is set up to interpret the results for you. So you don't spend much time on, analyzing the data, but you just have the results shown, so you report on it. And also it shows you all the equations in the background. Everything is hidden, but there's a messy ton of work in the background here. It's just hidden, and only the result is shown here. So to recap, multiple linear regression is carried out when a dependent variable is dependent upon two or more independent variables and not a single variable. That is when we do multiple linear regression. And the output of a multiple linear regression, you get a multiple linear equation of the influence of the independent variables on the dependent variable.